Find the power loss in friction assuming the first one is uniform pressure and the second theory is uniform wear. So we have to find power loss in friction. First theory assuming uniform pressure theory and uniform wear theory. When a vertical shaft of 100 mm diameter rotating at 150 rpm rests on a flat end footstep bearing, the coefficient of friction is equal to 0.005 and the shaft carries a vertical load of 15 kilonewton. Okay, here the mission element is flat pivot bearing or footstep bearing. Flat pivot bearing. What is the another name of flat pivot bearing? Footstep bearing. Flat pivot bearing is also known as footstep bearing. So this problem comes under bearings concept. Okay, so we have footstep bearing or flat pivot bearing. In general, bearing is a term. First of all, let us discuss about bearing. So what is bearing? What is the use of bearing? Bearings are generally used to support shafts, rotating elements. More in general, okay na? Shaft. Okay, shaft ni support cheyadaniki మనం bearing యూజ్ చేస్తాం జనరల్ గా చెప్పుకుంటే ఇన్ఫార్మల్ గా. We have to find power lost in friction. Okay, here you given flat pivot bearing or footstep bearing. Okay, you given two theories. The first theory is uniform pressure theory and one more theory is uniform wear theory. Actually bearings are designed based on two theories, uniform pressure theory and uniform wear theory. So we have to find power lost in friction. So power lost in friction is given by P is equal to, so what is the formula? 2 pi nt by 60. Power lost in friction is given by 2 pi nt by 60 and units watts. Okay na? So power lost in friction ki formula 2 pi nt by 60 basic formula is. Okay na? Here 2 pi n is speed. Okay na? So speed of the rotating element or speed of the shaft. Okay, so speed of the shaft manaki question already ichchadu. And T ante enti ikkada what is T? T means frictional torque. Frictional torque in Newton meter. So how do we get frictional torque? Idi ela vastundi? From uniform pressure, frictional torque T is equal to 2 by 3 mu WR. So uniform pressure theory aithe idi formula. Uniform wear theory, what is the formula for frictional torque? 1 by 2 of mu WR. We are going to use this formula and this formula in case of uniform pressure theory. So uniform pressure theory base cheskoni power find out cheste, if we calculate power lost in friction using uniform pressure theory, in place of frictional torque we have to consider this formula. Suppose if we design or if we calculate power lost in friction using uniform wear theory, we have to use frictional torque formula of mu WR. What is mu? Here mu means coefficient of friction. What is W? W means radial load. And what is R? Here R means radius of the shaft or radius of the bearing surface. Okay na? So radius of the bearing surface deniki equal avutundi in general. Okay na? Suppose there is no very minimum, very small clearance, chaala chinna clearance undi shaft ki bearing surface ki. Okay na? So what is general ga footstep bearing ela untundi manaki diagram? If you consider this is shaft, and this is bearing. Okay, so here the clearance between bearing and shaft, clearance between this bearing and shaft is very small, negligible. So అందుకే diameter or radius of bearing surface దేనికి ఈక్వల్ అవుతుంది? radius of shaft or diameter of shaft దేనికి ఈక్వల్ అవుతుంది? diameter of bearing surface. ఓకేనా? this surface is called bearing surface. ఓకేనా? so anyway already given radius of shaft in question. diameter is given, we can find radius. okay, so ఇప్పుడు మనం ఈ ఫార్ములాస్ యూజ్ చేసుకొని పవర్ లాస్ ఇన్ ఫ్రిక్షన్ ఫైండ్ అవుట్ చేస్తాం. so first let us assume uniform pressure theory. So now we are going to find power lost in friction according to uniform pressure theory. Uniform pressure theory, what is the formula for frictional torque? Frictional torque of the bearing T is equal to 2/3 into mu WR. First of all, what is mu? Mu means coefficient of friction. How much you given coefficient of friction? You given 0.05. Let us write all the given data. And W means, what is W? Radial load. Mu means coefficient of friction. W means radial load. How much you given? 15 kilonewton. Convert it into newtons. So 15 into 10 cube newtons. Next, what is R? Radius of the bearing surface. Here R means radius of shaft or bearing surface. If they are having very small clearance. Okay na? So here how much you given? Diameter is given. Actually given diameter how much you given? You given 100 mm. For 100 mm diameter, what is the radius? Radius is equal to half the diameter. So R is equal to 100/2. You will get R as 50 mm. Here R is equal to 50 mm. Now we have all the values, and also given speed of rotating shaft or vertical shaft. Speed N is equal to 150 rpm. Now we have all the values. Okay, let us calculate frictional torque T. So values అన్ని మనం ఇప్పుడు గ్యాదర్ చేస్తాం. ఇప్పుడు ఫ్రిక్షనల్ టార్క్ ఫైండ్ అవుట్ చేద్దాం. ఓకే, సో ఫ్రిక్షనల్ టార్క్ ఫార్ములా 2/3 into mu. So mu value how much? Coefficient of friction 0.05 into W value how much? 15 into 10 cube into next radius. So radius is 50 mm. So we have to convert mm into meters. 1 mm equal to 10 to the power minus 3 meters. Okay na? So say plus 10 cube 10 cube 10 power minus 3. These two get cancelled, and T is equal to 2/3 into 0.05 into 15 into, or let's do one thing, 15 50 is how much? 750. So T is equal to 2/3 into, what is the value of this? 0.05 into 750. So if you calculate, you will get 37.5. Then T is equal to, again calculate 2/3 into 37.5. So 2/3 into 37.5 నువ్వు చేస్తే, సో ఎంత వస్తుంది? 2 into 37.5 how much? 75/3. So 3 ones 325. So 25 Newton meter. So frictional torque T is equals to 25 Newton meters. Now we need power lost in friction. Okay. So friction వల్ల ఎంత పవర్ లాస్ అయింది బేరింగ్? సో పవర్ లాస్ ఇన్ ఫ్రిక్షన్ P is equal to capital P. Formula 2pi nt/60. 2pi nt/60, or we have one more formula, T into omega. So omega means angular speed. So omega is equal to 2pi n/60. radians per second. Okay. So now P is equal to, let us use this formula, 2 into 5 into N means speed of the vertical shaft given 150 rpm into torque, frictional torque 25 by 60. So P is equal to 2 ones and 2 30s, 0 0 cancel, 3 ones and 3 5s. So 5 into 25 means 125. So P is equal to 5 value 22 by 7 approximate value into 125. If you calculate, you will get 392.7 watts. This much power lost in friction if we consider uniform pressure theory. So uniform pressure theory తీసుకుంటే ఇంత పవర్ అనేది లాస్ అవుతుంది బేరింగ్. నెక్స్ట్ let us assume uniform wear theory. Uniform wear theory. Suppose if we consider uniform wear theory, frictional torque of the bearing T is equal to half of mu W, 1 by 2 mu W. So T is equal to half. What is the coefficient of friction? 0.05 into W means radial load. Given 15 kilonewton, converted into newtons. So 15 into 10 cube. And what is R? Radius of bearing surface or radius of vertical shaft. So 50 mm. So 50 mm means 50 into 10 to the power minus 3 meters. So what is the unit of frictional torque? Newton meter. So T is equal to, so 2 ones and 2 25s, 0.05 into 15 into 10 to the power of 3 into 25 into 10 to the power of minus 3 plus 10 power 3 minus 10 power 3, 10 power minus 3 get cancelled, these two get cancelled. Yes. So 0.05. So 0.05 can be written as 5 by 100 into 15 and into 25. So 25 ones and 25 fours. T is equals to 5 15 75 75 by 4. So if you calculate, you will get 18.75 Newton meter. Okay, this is the frictional torque of the bearing material when we consider uniform wear theory. So now power lost in friction. Power lost in friction assuming uniform wear theory. P is equal to 2 pi nt by 60. So here frictional torque in case of uniform wear theory we got 18.75 Newton meter. Now substitute all the values. 2 into pi into n value 150 rpm into torque 18.75 whole divided by 60. So 2 ones, 2 30s, 31s and 35s. So P is equal to pi into 5 into 18.75. Okay. So pi value 22 by 7 into 5 into 18.75. If you calculate this, you will get the final answer as, so power lost in friction 294.52 watts. 52 watts. This much power lost in friction if we consider uniform wear theory.